Scientists may have just found a surprising way to solve one of the biggest mysteries in modern cosmology, the Hubble tension. For decades, astronomers have known that the universe is expanding. The speed of that expansion is measured using something called the Hubble constant. But there's a major problem. Different methods give different answers. When scientists study the early universe, using the cosmic microwave background, they calculate one value for the Hubble constant. But when they measure the modern universe, using exploding stars called supernovae, they get a noticeably higher value. This disagreement is known as the Hubble tension, and it has puzzled scientists for years. But now a new idea suggests the answer might come from one of the most violent events in the universe, black hole collisions. When two black holes collide, they create ripples in space-time called gravitational waves. These waves travel across the universe and can be detected by observatories like LIGO. Since 2015, scientists have already detected many of these cosmic collisions. However, most black hole mergers are too distant or faint for us to detect individually. Instead, they create a faint background signal, a kind of cosmic gravitational wave hum. Researchers believe this background signal could hold the key to measuring the universe's expansion in a completely new way. By analyzing the strength and distribution of this gravitational wave background, scientists can estimate how quickly space itself is expanding. A universe that expands faster spreads black holes farther apart, which changes the overall gravitational wave signal we observe. This approach is sometimes called the stochastic siren method, and it offers a completely independent way to calculate the Hubble constant. Early results suggest the method may favor the higher expansion rate seen in modern universe measurements. If confirmed, this could help settle the long-running debate without rewriting the laws of physics. Right now, current gravitational wave detectors may not be sensitive enough to fully measure this cosmic background. But future upgrades and next-generation observatories could change that in the next few years. If scientists can detect and analyze this faint cosmic hum, black hole collisions might finally help answer one of the universe's biggest questions. How fast is the universe really expanding? And in the process, they might solve the Hubble tension once and for all.